everyone, welcome to Thailand off grid. Today we are testing our water.
I have this little multi-tester. It tests like pH level, ppms, which is part per million, and ppb, parts per billion for contaminants and other things. So we're going to be checking out our water. We're going to be taking a sample from the lake, from our well, and from the house because we have reverse osmosis water that we buy for drinking. So let's start.
The first water we are testing is the lake water. So here's the lake water. We're gonna see how that is. I think it's gonna be good water because we have fish and everything in it, and they're very happy and populating very good. So now we are by the well water. I'm not going to take it directly from the well, of course, but it's sitting in here a while until we're using it for the bathroom, like showers, toilet water, washing hands, face, whatever you need. So here's the well water. Looks way better than expected. So we are by the last part of the water that we are testing. It's the RO water that we are drinking. So let me show you guys how this machine works. So here's the water on the bottom. So it's pure water. RO is called reverse osmosis, and it's for drinking and cooking and whatever you need. It's 100% water. It can't get purer than that. So let me take water for you and then let me test it. Okay guys, here's the water. The reverse osmosis water for drinking.
Alright guys, so now we're going to do the test. I've got everything set up over here, so this guy here is my cheat sheet. So you guys don't have to look up all the stuff on Wikipedia. I have all the answers here for all the testing that I'll be doing. So here you have your lake water, your well water right here, and your reverse osmosis water here that we buy for drinking. So we're going to test all three of these here and then see what happens. So here's the tester, and we're going to see what we'll get out of this guy. Alright, cross your fingers. Hopefully my well water is close to drinking. Possible. I mean, if it tests good and they don't have a lot of bad stuff in it, I don't think I can test for parasites with this. I don't see how. But maybe there's someone could tell me in the comments if there's a way to test parasites with this. But we'll be going through a lot of tests. So I can always boil the water once I know there's not a bunch of product in the water, but I think it'll be good. Alright, so let's check this out here. Oh yeah. Multi-purpose. This will test 7 things. So there we go. Okay. And I also have my flush water. This is the water that I'll be using to clean this thing every time I do a test or test a different water. Okay, so if we turn this on here, you'll see lights up, full battery over there, and right away, I don't know if this camera could pick it up, but that little thing there says pH on top of this number. So the first test we're going to be doing is pH. will actually test everything in each one, so I only have to clean this device when I'm finished testing all, because there's 7 tests for each cup of water that I have here. So the first one is pH. pH is potential of hydrogen. The next is ppb, that means parts per billion. Then you have MV, which is millivolts. We have US/cm, and that means electric conductivity. It's the same as EC, or used to test EC numbers. ppm, parts per million, is the next. We have salt percentage, salt SG. That is SG standing for special gravity. So all of these things that I've been looking up for this tester, I do have the EPA recommendation online or on the internet under Wikipedia to show what is safe, considered safe drinking water, and what is not. So we're trying to obviously hope that all the parameters are within the safe. So each one that I test will be going over the parameters. I'll be writing them down, and then we can compare notes between all 3 of the water, and we'll see how good or bad the well water is and how clean or not clean the lake is. Okay, so first one we're doing here is our lake water. So what I'm doing, guys, is I'm shaking it around, letting it settle. So don't know if the camera can pick that up, but that's 80 Fahrenheit. So right now we're at pH for our lake water. That's 7.47. Next test for the same water. Right now it's saying 0, which is really cool. That is parts per billion, ppb. So that's at 0. Next test is millivolts, and that's sitting here. Numbers still going up. It's at 53. Now 52, 53, teetering between both of them. And now from 51 to 53. So I'm going to put down the average, and that'll be 52. So 52 millivolts. Here's the next. We've got USCM, or EC, electronic conductivity. The number for that, US-CM, 1,656. Okay, then the next test will be ppm. A lot of people know what that is. So that's parts per million. We have another test before that said parts per billion. That said 0. So now maybe we'll get some numbers. And already we do. So it's settling in, and we have 825 parts per million. Next test is salt ppm. That's salt parts per million. Number settling right around 826. Next test will be salt percentage. Oh, that's from the lake. That's actually impressive. That's at 0.08%. Sounds good to me. Then the last test for this water is salt SG. SG meaning special gravity. 1.0 0.000. Now that we have the first water tested with my little plan here, my little spreadsheet, I have now some neutral water so that I can rinse all that stuff off, that dirty lake water. Okay. Okay, take that, and I'll be wiping that over here on a new, clean, fresh, clean surface. Okay, so our next test will be our well water. So we're getting from the worst to the best. Okay, so let's get that in there in the well water. And let's see if there's a difference in the pH between the lake and the well. So let that sit there for a little bit. And seems to be stable at 7.61 on the pH, possible hydrogens pH level. Next test will be the parts per billion, ppb. We're at 0 ppb, parts per billion. Okay, and here go the millivolts. Okay, there is a difference between the lake water and the well water. Yeah, and I'll be disclosing all the differences. I'll show you my little cheat sheet, my little data paper after I'm finished. And I know it's handwritten, but it'll be real data. So, you can check that out. So, millivolts are at 73, stable. Next, we'll be testing electrical conductivity. And what it says is US/CM, but here on Wikipedia, it says that US/CM is used for testing electrical conductivity. Oh, there's a sizable difference between the lake and the well. You like the end result between all of these numbers. They're not close for a lot of these tests. I don't know if that's a good thing or a bad thing. We're going to find out together. So this one is stabilizing at 2,520. Next test. ppm, parts per million. So that'll be 1,254 ppm. So then the next is salt ppm. Salt ppm, it's at 1,254. I'm seeing a pattern here with my test, meaning that ppm and salt ppm basically give you the same number, but maybe not all the time. I'm not sure why the device would have two of the same exact things just labeled differently. So we'll push forward and we'll check that out together. Salt percentage. So salt percentage in my well is a little higher than my lake. So that's at 0.12%. And next we're testing is salt SG. So it's the same at 1.000. Okay, that concludes that. Let me clean. Clean that up here. Okay. Now we're going to be testing out my drinking water, so I hope that's good. That's the reverse osmosis on the end. So we're starting again with or possible hydrogen, which is pH. In Fahrenheit, the lake was at 80 Fahrenheit. The well water was at 78 Fahrenheit. And the RO water, reverse osmosis, is at 77 Fahrenheit, just for those who need to know. Okay, pH is stabilized at 7.98. Next test. We've got our parts per billion, ppb, 0. All of them were tested at 0 for ppb. Next test is millivolts. Okay, so 137. Okay. Next will be the USCM, electrical conductance. So the electrical conductance of the reverse osmosis water is only 10. And I say only 10 because the other waters, the lake water is 1,600 something, and the well water is 2,500 something, and the reverse osmosis is only 10. So there's something there. You got to pay attention to the difference between the reverse osmosis and the water under the ground. Next test. ppm, parts per million, 5. While the other waters are a lot more. We'll go through that after. So let's get through the test. 5. Then we've got salt ppm, also 5. I think they're the same test. Salt percentage, 0.00. Zero salt, no salt in reverse osmosis. Alright? And finally, salt SG, which is the same as all the others, which is 1.000. Okay. So, let's clean that off there. Okay, so guys, that was one round of testing. So, I'm going to turn the camera off just for a couple minutes to redo the testing and make sure that my numbers match. Then we're going to have our talk. Stay tuned. Alright guys, I've got all the answers here. Tested it 3 times and made sure that I got stable numbers because, you know, they fluctuate. So I wanted to make sure I have accuracy. Okay, now we're going to go through the results, the fun part. So, with pH, that's possible hydrogens, pH 7 being neutral. So recommendations for healthy drinking water to 6.5 to 8.5, the recommended from World Health drinking water. So if we look here, the RO water is right at the minimum, so that's 6.81 is the reverse osmosis water. Then the well water is 7.44, which is also in the safe range for drinking water, for pH measurements, not all measurements. Then for the lake, we have a pH of 7.6. So everything is actually between 6.5 and 8.5 for the World Health Organization. That's on the Google. on Google. All right. Then we have our parts per billion. The EPA says on that one, for anything under 15 parts per billion is safe, being the goal, or the goal being 0, of course. And I have 0 across the board. The next one is millivolts. Millivolts, I have for the lake 134, for the well 152, and for the reverse osmosis drinking water 137. EPA suggests drinking water of around 250 millivolts is okay, while swimming pools have about 650 millivolts. I'm under that 250 millivolts, right? We're well under 200 for everything across the board. The next test, the US CM, CM being centimeter and the US being microsiemens. Okay, I'm sure I'm not pronouncing that right, but that is how it's written. So, for our lake water is 1,628. For the well water is 2,464, and for the reverse osmosis water, that's 10. Safe being between 200 and 800. So reverse osmosis way less than 200. My well water and lake water much higher than that 800. So I don't believe I'll be drinking that water. I don't know if the electric conductivity is a problem when you're drinking that. It says it's safe from 200 to 800, doesn't say any higher, so I'm sure that'll be a problem factor in trying to convert this water into drinking water. All right, next test will be parts per million, ppm. So parts per million, safe consumption, that is a relationship to total dissolvable solvents. That's a TDS. So this is how you get that number through this measurement. So safe for drinking water. Highly purified drinking water would be anywhere from 0 to 50 ppm, parts per million. Safe drinking water, non-purified but safe drinking water, will be 50 to 300 ppm. Let's see what I've got. So for our lake, it's 811, not drinking that. Well water, it's even higher, 1,226 ppm. And then the reverse osmosis, 5. So there's that. Next test will be salt, ppm, which is the same. Okay, so next test would be the salt percentage. Of course, you don't want to be drinking salt, so depending on how much, right? So the salt in the lake water is 0.08%. The salt in the well water is a little higher, 0.12%. And then our reverse osmosis water, drinking water, that is 0. Then we've got our last test, specific gravity. So this test is the salt specific gravity, and they all have the same reading, which is 1.000. Now that I've tested the water, I can conclude that the reverse osmosis water is the safest water to drink out of all three. The ppms are a little high, they're higher. They're too high for drinking. It says highly purified water for the ppms. I think I've mentioned this already, but I will again reiterate. 0 to 50 ppms for highly purified water. For good quality drinking water is from 50 to 300 ppm, parts per million. And then acceptable drinking water is 301 all the way until 500 parts per million. So if you're over that 500 parts per million, I don't believe it's safe to drink. That doesn't mean we can't boil the water and then do another test on that, which I could do another video on that, to see if we could save our well water and turn it into safe water by boiling it. Because if you boil any water, technically you could drink it, right? Well, I would like to find that out. Going through a lot of learning to live on this new lifestyle on homestead, where you're growing everything and depending on yourself instead of the dollar or the baht or the euro or whatever your currency is. But I don't want to depend on money to live, even though you do need money. I would like to minimize the amount of spending needed so I can take care of all the rest myself. As a human being, we should be able to provide for ourselves, right? I mean, the whole reason why we're doing this is to get away from being dependent on the grid. You know, a lot of people say independent, independent, but you're only good until your structure or the infrastructure, I should say, of any city or town that you're living in crashes, right? So when you get a power outage, you don't have power. If the water goes bad, you're not going to touch the water from the pipes, right? So we have our own power, we have our own water, we have our own food coming. You know, we have rice, we have fish, and they'll be growing vegetables and fruits. So we'll definitely be able to work on those things. I hope you guys enjoyed this long, agonizing water test, but for me it was also important that I know what's going on with our water, to see if it was even close to drinkable or not. And with these numbers, it's close. There's some things that need to be adjusted, but there is also the fact that I don't believe this can test for parasites. That I believe I have to boil off the water regardless, or have a reverse osmosis membrane, reverse osmosis system, that I can then strain everything out of that. But there are a lot of good trace minerals in the well water. You know, you have magnesium, you have zinc, you have a lot of good things that come from natural well water that I wouldn't want to use the reverse osmosis process to strain out. I want to be able to collect the benefits from drinking that natural water. I don't want to get contaminated or infected with any parasites, so I'm not going to try that until I do more research. But today was the test with the multimeter to see where we're at with our numbers, and just general test to see how bad or how far off they are. Parts per million. I'm glad that we don't have a lot of iron or lead in the water, so that's a really great thing. So I think it's actually really close to drinking water. pH levels are drinkable for all of them. Also with the millivolts, there's a bunch of tests that came out A-OK. I don't think that the salt was that bad of a factor, the amount of salt in the water. So let me know what you guys think. I hope you guys join us again, and we'll have another update video on the water test later when I figure out how to test for microorganisms, bacteria, parasites, that kind of stuff, because this tester, unfortunately, I don't believe does that. Alright guys, stay tuned.
Thank you for watching Thailand Off Grid. I hope you guys enjoyed the video with the water testing.
Yes, and we will have on our next video a little bit personal, in-depth, like a questionnaire thing. Basically, all you guys on the comments have a lot of questions, and we'd like to help answer them. So stay tuned for our next video, and then you get to see all the reasons why we've made the choices we've made to get where we are today. Okay? So enjoy. Thank you for watching again.
Thank you very much.
And see you back next time on Thailand Off Grid.
Like and subscribe.